So this is the classification of variables that is discussed in the previous lecture. So now first is our based on causal relationship, we have four types of variables. That is independent variables, dependent variable, extraneous variable, and intervening variable. Independent variable is always the cause which is responsible for bringing about change. Now, in my case, what is the cause? I am bringing electric vehicles into or on the road. So there is reduction in the levels of air pollutants. So electric vehicle, introduction of electric vehicle is a cause. So in my case, independent variable is electric vehicle, right? Or maybe petrol vehicle, diesel vehicle, which are increasing the levels of air pollutants. So independent variable will have its influence on the dependent variables. Okay, so dependent variables will either change in the form of increase or decrease of in terms of the quantity, in terms of the amount. So independent variable is always the cause. So in my case, it is the cause, that is electric vehicle, that is introduction of electric vehicles, that which is responsible for reduction on air pollutants. Electric vehicles, they have its impact on these air pollutants, right? So it is independent. It is not dependent on air pollutant. Because air pollutants are gone down, can you say that the electric vehicles are then on the road? So it is not reverse way. So independent variable will always have its influence on dependent variable, but dependent variable will not have its influence on independent variable. So independent means the name itself suggests that it is independent of any other variables. It is the cause, basically it is the cause which bring the changes, or which has its influence on other variables, especially dependent variable. The outcome variable, dependent variable is what? Next is dependent variable. That is always outcome variable, or outcome means whatever change is happening. Now, what I am doing, I am introducing electric vehicles on the road. So the result is, the outcome is in the form of reduction of air pollutants, right? So dependent variable here is reduction of air pollutants, or air pollutants like PM 2.5 particle level, PM 10 particle level, carbon monoxide. So all these are my dependent variables, because their quantity in the air is totally dependent on the type of vehicle used, or it is dependent on independent variable, that is type of vehicle is independent variable. If I am using petrol and diesel vehicle, the levels of these air pollutants are going up. If I am using maybe a CNG vehicle or hydrogen vehicles or electric vehicles, their levels will go down, right? So dependent variable is always outcome variable. Outcome means the changes which happen in that particular variable, either increase or decrease of that particular variable levels. Extraneous variables means several other factors which operate in real life situation. Now, what are these extraneous variables or several other factors? Now, these several other factors means, suppose I am introducing electric vehicles in the area, DY Patil University area, which is in the Nerul. So opposite DY Patil University, suppose there are many factories or many industries are present. Now I am introducing these electric vehicles on the road, and what I am thinking, these electric vehicles will have its influence on the air pollutants, means it will help to reduce the air pollutants. But simultaneously, industries are present. Industries are present in the nearby areas, and they are also eliminating similar kind of particles, maybe PM 2.5 particle, PM 10 particle, or sulfur dioxide, carbon monoxide, and there is added effect. Means suppose after introduction of electric vehicles, or before introduction of electric vehicles, suppose I measure the levels of air pollutants, maybe PM 2.5 particle level you consider, and if it is 120 cubic millimeter, I introduce electric vehicles, I run electric vehicle for 3 months, and again I measure the levels. Maybe every day I am measuring level, and my average level after 3 months is 60 cubic millimeter. So what you can say? You can say that there is 50% reduction in the levels of air pollutants. Now, since industries are present in the nearby areas, now these industries are also eliminating similar kind of particles, similar kind of air pollutants. So you will not get that level. So after 3 months, your level may be 80 cubic millimeter, 70 cubic millimeter, 75 cubic millimeter. So that will be 50% addition of what is expected. Here, what is happening? What is expected, or what is ideal situation? Your independent variable, that is electric vehicle, should act only on the dependent vehicle, that is air pollutants. But this is not happening here. What is happening? Industry pollutants are also, or industries are also influencing factor. Industries are acting as independent variable, and they are also influencing dependent variable like air pollutants. And because of that, the levels of air pollutants are going up. Now, what you have to do? You have to subtract these extraneous variables. Suppose after introduction of electric vehicles, and even there is presence of these industry related pollutants, if the level is 80 cubic millimeter, and you calculate the levels of industry pollutants as 20 cubic millimeter. You can subtract that level and you will get final level as 60 cubic millimeters. So what you can say? You can say that there is 50% reduction in the levels of air pollutants. Okay. But before that, you would have said that there is only 25% reduction rather than saying 50% reduction. Okay. So this impact you have to identify. Whenever you are conducting any kind of study, you have to identify which are extraneous factors. Extraneous factors means which are other factors which are present in real life situation. See, many times we work in a real world. It is not always the laboratory. Very few people like biotechnology people or bioinformatics people, they work in a laboratory environment where they can adjust the temperature, they can adjust the environment, maybe they can adjust the humidity, all the parameters they can control. But in real life situation, it is not difficult when you are dealing with the humans, when you are dealing with the machineries, or when you are dealing with the outside environment. Can I close the industries? Nobody can close the industries because it is not our portfolio to close the industries, right? So we cannot interfere in that part. So rather than focusing on other agendas, you can measure the levels. You can measure the levels of these extraneous variables, and you can subtract from its impact on the dependent, its impact on similar to independent variable. So you will get exact impact of independent variable on dependent variable. So extraneous variables are nothing but several other factors operating in real life situation that change the dependent variable. That change the dependent variable means that may increase or decrease the magnitude or strength of relationship between independent and dependent variable. Means in my case, there is change in the magnitude between independent and dependent variable. If I am only using independent variable, the levels are 60 cubic millimeter. But if the industries are presenting as extraneous variable, so there is addition of 20 cubic millimeter, right? So total effect, if you get in presence of industries only 25%. But if you deduct the industries, if you subtract the industry, the actual effect of independent variable is 50%, 50% reduction. Okay. So 25% means and 50%. So there will be drastic difference whenever you conduct your study in real life situation. So whenever you are conducting any kind of study, just think of what are extraneous factors that are affecting my dependent variable. That is the most important thing. Next is intervening variable. Intervening variables means basically it is a linking factor. It is a confounding factor. So I will give you example of our high school days when we used to do experiments in our chemistry lab. Suppose we have three chemicals, chemical A, chemical B, and chemical C. Now, generally what happens when we mix with chemical A and chemical B, what is expected? Chemical A should interact with the chemical B. But in this case, what happens? Chemical A, when you mix with the chemical B, you don't see any interaction. You don't see any reaction. When you add chemical C, you will see the reaction. So chemical C is acting as the intermediate link, the link between chemical A and B. If chemical A has to act on the chemical B, what is required? Chemical C is required. In presence of chemical C, only that reaction is happening. If chemical C is not present, chemical A will not have its impact on chemical B. So my chemical A is independent variable, chemical B is dependent variable, and chemical C is intervening variable. So if intervening variable is present, if chemical C is present, then only in presence of chemical C, chemical A is acting on the chemical B and its influence is seen. And you can see the outcome variable effect, right? So that is intervening variable. So it is also called as confounding variable. It links independent and dependent variable. In certain situation, the relationship between independent and dependent variable cannot be established without the intervention of another variable. And this variable is called as intervening variable, right? So intervening variable, you can have multiple examples. Even during Corona also, like many people got Corona, but very few people died. So how do you explain that? All the people, what is ideal situation? Your independent variable should have maximum impact on dependent variable. All those people who got Corona, they should have been died. Okay, but that was not situation. Very few people died. So there were so many theories you have seen in the maybe newspaper, or you must have seen on news channels, or maybe scientific discussions. Suppose there is one theory like cytokine storm. So those people who got Corona and those who developed cytokine storm, they died. So corona infection or COVID-19 infection is independent variable. Outcome variable or dependent variable is death. So corona infection will have its impact on death or independent variable only in the presence of cytokine storm. So those people who experience cytokine storm, they died. Though those people who did not experience that cytokine storm, they survived. Okay, so that is intervening variable. Okay, it's a connecting link. Without that, the outcome variable will not have not be influenced. So for influence or for impact of independent variable on dependent variable, we need linking agent or linking variable, and that linking variable is called as intervening variable. Got it?
Sir, I have to ask one question, sir. Uh, can you hear
Yeah,
me,
tell
sir?
me. Yeah, I can hear.
Sir,
Go ahead.
yeah. So in the previous slide of independent and in the same example of COVID, so the cytokine storm is a dependent variable, and dependent intervening variable is the cytokine storm, and the dependent variable is the death, and independent variable is the COVID himself. Am I correct, sir?
Yeah, right.
Sir, my study is on the boxers injuries. Like I want to do a study on the elite Indian boxers, which kind of injuries they suffer. So I, जो independent variable will be the injuries which occurred either on the entire, say, face, hand, lower limb, and what will be the dependent variable, sir?
Injury is the dependent variable. See, because of boxing, there is injury. Because of boxing, there is development of diseases. So boxing or the traumatic incidents is the independent variable. And whatever diseases, maybe they will have fractures, they will have some other diseases, that disease part will be your outcome variable or dependent variable. So you have to measure that disease outcome. Maybe suppose because of punching, because of particular type of punch, if there is a particular type of fracture. So that you have to identify. So your type of fracture, type of
Type of
trauma,
injury,
type
let's
of
say
injury.
laceration
Yeah.
of lips, it's a
Yes.
dependent variable.
Maybe soft tissue injury, bone injury,
Yes,
or maybe some visceral injury or organal injury. So you can classify it based on the type of punch, based on the type of trauma. So trauma, punch, or any other activity is your
will be
independent
my
variable.
dependent variable.
Yeah, and the disease which is developed because of that trauma, because of that influence of trauma, is the
Yes.
dependent variable.
Okay, sir. And sir, what will be the extraneous variable and intervening variable, and is it necessary that every study has all these four variables?
See, it is not necessary that all the four variables are present. It is see, independent and dependent variable are mandatory. Without that, it won't be a cause and effect
Yes, sir.
relationship. So independent
Yes.
and dependent variable will be present by default. There is possibility that extraneous variable and intervening variable may be present or may not be present. Okay. So in your case, you have to identify whether there is an extraneous variable. In your case, there
Like
is less possibility that there is intervening variable, because when I hit somebody on face, there is going to be some trauma, maybe in the form of fracture or soft tissue injury or maybe some trauma. So there is
yes.
less possibility of intervening variable in your case, but maybe there is possibility of extraneous variable. Suppose, yeah.
Yes, so extraneous variable will be like face guard. They wear face guard, and few players in the competition they don't wear face guard as per the IBA rule. Now they have again introduced the face uh, guard for the boxers. So I have that face guard will be the extraneous variable for
No, that
the.
will be different group actually. That cannot be extraneous variable. AC extraneous variable, it is a part of your study. So that
Okay.
face guard or that guard is preventing the magnitude of trauma, or you can say the depth of trauma is prevented because of that guard. So it is a part of your study. That cannot be extraneous variable. It is internal part of. So you can divide into groups with guard, without guard. That way you can study, but it cannot be
So
extraneous variable.
part of dependent only,
Extraneous
sir.
variable means suppose. Yeah, suppose I will give you example. Suppose somebody is having weak facial bone because of previous trauma. Suppose somebody suffered a severe car accident injury, and because of car
Okay.
accident injury, maybe 5 years back, that person had many fractures on the facial area, and now that these fractures are healed. But bone is
Okay.
not that strong. So bone has weakened. So that can be extraneous variable. So you can consider this factor, like the person
And
who got
history of
severe
previous
injuries.
injury will be extraneous variable.
Yeah. Previous injuries. Previous injuries means magnitude is important. What
Yes.
was the magnitude of previous injury? Were they crush injuries, or were they superficial injuries, or were they deep injuries? or the bones were crushed, that also matters. If all the bones are crushed, suppose somebody has a severe car injury or car accident, and if most of the facial bones are crushed, so it will take some time for healing, and even that bones develop some weak areas for further fracture. So this kind of
Got
things
it.
will be your extraneous variables.
And
Any
so
other
there will be
injury,
no intervening variable in my study.
least possibility relatively, because suppose you hit somebody on the face, there will be some
Yes.
kind of body reaction, like body will be react in the form of trauma to maybe lip or face, or trauma to bone, it will fracture. So there will be direct impact. There is no intervening variable required in your study. Like in
Yes,
my
sir.
study, electric vehicle and air pollutants, no intervening variable is required.
Yes, sir. And one more thing,
Example, I
sir.
just,
Mhm. Like
yeah.
in the previous session, one of my colleague had asked about their research on the oromaxillofacial carcinoma. So in that same study, there will be no intervening variable, or there will be a intervening variable.
No, in this case also there is no. Suppose you are talking about maybe oral cancer.
Yes, sir.
If a person is chewing tobacco, there is greater possibility that that person will get this what you say, oral cancer. If person
Yes,
is
sir.
not non-tobacco chewer, he will there is lesser possibility that that person will get the cancer. Means there is influence of tobacco on development of cancer, and there is no intervening variable required. Like patient is using tobacco, so tobacco will have its direct influence on oral cavity, okay, and it will show its influence in the form of development of cancer. So there is no
So
intervening variable required in this particular case. Yeah.
and so tobacco will be the extraneous variable.
No, tobacco will be independent variable. No, tobacco
Tobacco
is
will be
because of
independent.
tobacco. Yeah, it is the cause. Tobacco is the cause for development of cancer. Outcome is cancer, and tobacco is the
Yes.
cause. So tobacco is the independent variable. That is the cause for development of cancer. That is outcome or dependent variable.
Okay. And then what will be the extraneous variable in that study, sir?
Extraneous variable means there are few cases like who are non-chewers, still they develop the cancer. So there are so many other theories also, like it is not the sole factor, right? It may not be the sole factor that will lead to cancer. So you can think of
Okay.
other factors which are responsible for development of oral cancer. Like suppose somebody is working in chemical industry or dye industry. So dye is also one of the contributory factor, or carcinogens are present in the dye. Okay, so such factors you can consider as extraneous variables, which
Thank you,
are
sir.
not having direct influence. Like patient or the person is not putting dye directly, but he's exposed to that particular carcinogen. But it is not common for all. Suppose you have only one person, or suppose your sample is 100, and out of 100 there are only one or two people. So either you have to segregate these, or you have to put it in a different way. Because if you mix it with the normal people, then there might
Okay.
be a shift of your average value and standard deviation. All the values will shift. So you have to
Got your
identify
point.
such extraneous variables. Either you have to control, you have to eliminate, or you have to delete it from your study.
Got it,
But
sir.
anyhow,
Got
you
it.
have to control these factors. Extraneous variable, you have to always control. And
Thank you, sir. Thank you.
hence we take control group. See, many of you must have done the studies, and in your study, many times you take a control group. So what is in by control group? Why do you take a control group? We are not taking it for the fun. It will control something. It will control the effect of extraneous variables on independent variable. So whenever I want to control the effect of independent variable on, extraneous variable on dependent variable, I will add this control group.
So, sir, in my study, there will be no control group. Like for the boxers, so who will be the control group?
The people who are suffering from other trauma. See, there is like
The same
boxers are
boxers,
getting
but
injury,
the same
similar
boxers
similar
got
injuries.
injured with some other thing.
Yeah, similar injuries induced by other things, like maybe other traumatic incidences, any kind of traumatic incidences, but not related to boxing.
Okay. Yes. Thank you, sir.
Sir, I have one question. Sir, it is compulsory to have a control group in any experimental or intervention study, or you can have a different groups experimental only.
it is always better if you are doing experimental study, like you ask about experimental study. When in study design, we will study in detail experimental study design. For experimental study design, always it is recommended that you should have a control group, because it will help you to, because you are experimenting something. Your study design is experimental study design. It's an interventional study design. So when you are doing any kind of intervention or experiment, it is always better to have a control group, maybe single control, or even you can keep double control group.
Okay. So, sir, just a doubt. So, my study will be on the beetroot juice supplementation and its effect on the different exercise component. So, what my plan is that the same group. So, first I'll measure them without the supplementation, though I will take the baseline without supplementing then the beetroot juice, which will be my control parameters. And then I'm going to supplement with the beetroot juice and then checking its effect on those parameters. So is that fine if the same people remains control and then I'm ingesting something and then checking the results?
You have to add a control group. Now your beetroot juice, you need to check the components. What are components in your beetroot juice? Suppose the proteins levels or other nutrients, vitamins, all that you have to find out. And you see a group of people who are having similar kind of exposure to these nutrients. Suppose I am taking one particular diet, or my routine diet at my home diet, but my home diet is such a way that whatever beetroot diet you are giving, the similar nutrients the other group people are getting. So you will have a control group who are having similar exposure in terms of nutrients, the nutrient value of the food. So that those people you can keep it as a control group to see the effect, of whatever you are checking, the effect of beetroot on whatever are your variables,
my
outcome variables.
question is, for example, there are 30 subjects, for example, and those 30 subjects, I am measuring their exercise performance right now, right? After that, I'm adding beetroot as an additional drink or a beetroot powder as a supplement to their diet, maybe say for 30 days. And I'm going to measure their performance again, which I measured 30 days previously. So that can remain the same, na? Because
Yeah, means you want to assess efficacy of
efficacy of
exercise.
beetroot, efficacy of beetroot on exercise parameters.
Okay. So see, exercise with beetroot you are checking. But apart from exercise, like suppose your subjects or your maybe your samples, they are having exercise. After that, they will have beetroot. Apart from beetroot, they will go home and they will eat other things also. So you should have one control group who is doing similar exercises and having normal home food. Understanding, but they're not taking the beetroot juice. So you have to measure the impact of exercise and normal home diet. Okay, you will get some value. You have also impact of people who are having exercise and you are giving beetroot. Also, they are going home and having similar diet. So that diet part you will exclude. What is your purpose? You want to check the impact or influence of beetroot juice on exercise. But at the same time, they are going home and eating some other things, or throughout the day, they are eating other things also, like other people. So you should have one group which will subtract that effect. Subtract which effect? Effect of home food or effect of other food. So that will, you will have one control group that is doing exercise and having normal food diet on whatever food is taken at home or whatever food is taken at other places. So that will be your control group.
Okay. Okay, sir.
Sir, these all four variables is in cause and effect studies or in correlation studies or too?
Cause and effect and correlation studies are. Correlation means, can you explain correlation? If you have any idea in mind. Correlation, just somebody gave the example, no? Tobacco and cancer. There is correlation. There is direct correlation. There is positive correlation. If you eat tobacco, there is greater possibility that the person will develop cancer, oral cancer. Or there is negative correlation between electric vehicles and air pollutants. If we use electric vehicles, levels of air pollutants will go down. There is negative correlation. So cause and effect and correlation, they are almost similar kind of things, but not exactly same, because taste of
Hello.
yeah.
Okay. Sir, so sorry to disturb. Sir, in the same way, if I want to study the effect of tobacco chewing on the healthcare workers in rural area in the development of oral cancer. So, in that sense, you have this stress factor also, which tends to develop, which actually relates with developing oral cancer in some or the other way. So, what is exactly stress in such case? What factor you can distinguish as stress?
See, if you want to add stress as your independent variable, you can add. But if you want to study sole effect, only effect of tobacco on oral cancer, that can be your objective. That can be your study area. Then apart
Okay.
from tobacco, maybe stress or the chemicals or maybe many other
Correct.
factors. There might be many other
Yes,
factors
yes,
also that could be contributory for
yes.
development, like
So, for
pesticides.
example, if I'm studying it on healthcare professionals, so there are all the doctors, ASHA workers, staff, and all that, if I can include. So, there are many factors which are related to that. So, do I have to just stick with the dependent and independent variable, or there will be more external variables also? Like stress will be an external variable, or I have to take it as a the independent variable? How to go with that, sir?
No, see, I think in your case, what is your objective? You want to assess the impact of tobacco, right, on
Chewing
healthcare
on
workers
healthcare professionals in rural area. That's what I'm
in
thinking,
rural
sir.
area.
Hmm.
Okay.
Yes,
So, see, stress, then it will be your additional extraneous factor in this case,
correct, correct.
because
Yes, sir.
your independent variable or study variable is tobacco, and you
Correct.
want
Yes,
to
sir.
assess its direct impact in healthcare workers of rural area in terms of getting cancer. So,
Cancer.
outcome
Correct, sir.
variable is cancers of
Yes.
maybe particular is community you have selected. That is the your part of study. It is a part of study design, like community, whatever you have selected. That is a part of sample. But
Okay.
stress is there, or maybe uh, vegetables or fruits with pesticide, or there might be some other chemicals also, or there might be some other, you also
Okay.
find out different causes of oral cancer development. All those will be
Correct.
your
Correct.
extraneous variables. So you will
External
have those
variables.
groups
Correct.
also. Yeah, you will have those groups also
Okay.
to
Okay. Okay.
study
Okay.
that way.
Mm-hmm. Okay. Thank you, sir.
Sir, I had a question.
Hmm.
I just wanted to know the exact difference between extraneous and intervening. So, is it that the extraneous variables are all the variables, and some of them, if I only control them across the two groups, they are called as extraneous, and the one that I actually study for its intervening quality, that becomes an intervening variable? Is that how it
No, no,
is?
no.
Or
Extraneous means unwanted.
okay,
Suppose you are doing some work, but there are certain unwanted elements that try to hamper your work. So extraneous means an unwanted elements. Unwanted elements means like when you are conducting a study, you want to assess your impact of independent variable on dependent variable. But there are certain notorious elements which are present in nearby areas that are trying to influence your dependent variable, that are trying to influence your outcome variable. And those are extraneous variable which are not required, which are unwanted. So whatever unwanted, whatever is either influencing the outcome of your dependent variable, that is your extraneous variable. Intervening variable is important variable. See, I gave example of three chemicals. Chemical A is independent variable, chemical B is dependent variable, and chemical C is intervening variable. When I add chemical A to chemical B, you will not see any reaction. But when I add chemical C to the mixture of chemical A and B, you will see the reaction. So what is happening here? Chemical C is acting as a bridge or linking factor that links chemical A to chemical B. That helps to have the impact of chemical A on chemical B. Chemical A will not have its direct impact on chemical B. It will have its impact only in the presence of chemical C, right? So chemical C is very important factor here, intervening factor here.
okay.
So it's a totally different. It is wanted factor. It is a required factor. It is must factor, essential factor. An extraneous variable, you want to run away from extraneous variable. You want to delete extraneous variables. You want to eliminate extraneous variable from your study.
Okay. Okay. So, for example, the last year we had conducted a study for the effect of music-based interventions on balance function in Parkinson's disease. So we had two groups, the experimental and the control group, and both the groups were given conventional physiotherapy. Experimental group was also given music-based interventions in addition to that. And so both groups were matched in terms of their age, gender, and severity of Parkinson's disease. So, and the to study the cause effect relationship, we realized that through literature review that the baseline levels of motivation based on the scale, those could influence the relationship. So that was also taken into the statistical analysis. So then that becomes an intervening variable, right? And
How it will become intervening? Like, was it did you find any connection? Did you find any
we
connection?
actually what happened finally is that the sample size turned out to be too small for that the correlation to be studied. But the original idea was that we will be seeing the
Can you
effect
repeat?
of
Amruta is speaking,
yeah
no?
yeah
Dr.
yes
Amruta,
yes
can you
yes
repeat?
yes sir. So it was the effect of music based interventions on balance function in Parkinson's disease. So the independent variable was the music based intervention, and the dependent variable was balance, which was measured using a balance scale. So that was actually the independent and dependent according to us. And then we realized through the literature review that the original levels of motivation with which the patient enters the therapy scene, that can have an effect on, or that can influence the effect of music based interventions. So
But
if
is it
the
mandatory? Is
original,
it mandatory?
so there is not a lot of literature, but a few studies were suggesting that. So we thought of taking that in to study if it is turning out to be. So what we had decided is we will see the change in the balance function from pre to post, and that we will be correlating with the baseline values of motivation. So to see whether
Amrita, then you have to do one more study, like the balancing function, like motivation. You should have a separate arm on a motivation, like those who are
okay,
motivated. So if you add a separate arm, you can have double control group. In this case, you can have
okay,
dual control.
okay,
You add one more arm in this, like those who are motivated, the people who are motivated, and those who are not non-motivated.
okay,
If you want to assess the impact, whether that
okay,
is intervening factor or that is extraneous variable. At this point of time, without proper data, you cannot come to some conclusion whether it is intervening or extraneous. It could be intervening also. It could be intervening, but in all case, it is not happening, right?
No, I mean the results
Uh,
actually will tell us whether it is intervening or not, right?
you have
We
to
just
measure the
measure the
you have to measure it. You can have
okay,
separate study on
okay,
the motivation part.
okay, okay.
If
And
you
so
measure the
what we
effect,
match, yes, sir.
if you measure the impact of motivation, how much is the
Huh.
impact of, whether it is 80% or it is just 10%.
Hmm,
Based
hmm,
on that, you can say, like in case of
hmm,
chemical
hmm,
A, B, C, if C is
hmm,
absent, the reaction is zero. Means
hmm, hmm,
nil, reaction is nil. Means it has maximum utilization, or it is must, it is required. So in
hmm,
your case, if it is a must factor, then it is
hmm,
your
hmm,
intervening variable.
okay,
Means suppose somebody
right.
wants to listen to music, that
Hmm,
ear should be proper. If that person
hmm,
is deaf, he won't be able to listen anything. So you will
hmm,
not have any impact. So
hmm,
essential factor is proper ear function, right,
hmm,
for listening the music. So
hmm,
in that, similarly, you have to identify whether it is a must factor or it is
hmm,
not necessary factor.
And if they were matched for their age and their disease severity, then those factors then will be called as
You are controlling.
extraneous.
No, if
They
yeah,
are
you are
controlling,
controlling
but
extraneous
then
variable,
they're
definitely.
extraneous. They're extraneous variables, then, right?
Yes, you are controlling the.
Okay,
Suppose
okay, okay.
there is a child of 5 years and there is adolescent of 17 years. So
Hmm, hmm,
definitely the understanding or
hmm,
learning capacity or this all kind of skills are different in these two. So you cannot compare a
hmm,
child who is of 5 years and with the child who is of 17 years of age, right?
hmm.
So you have to
Okay,
match. So
yes,
here you are
yes.
controlling. This is also controlling extraneous variables.
Okay, okay,
Suppose your
okay.
study has a child of 5 years also, 17 years also, and then an adult of 37 years also, then
Hmm,
then the results will not be uniform. So
hmm,
that is extraneous variable. So what you are doing,
hmm,
you are matching. It is called as matching,
hmm.
matching to control the effect of extraneous variable.
Okay, yes, sir. Got it.
Based on the study design, we have active variables and attribute variables. Active variables are the variables that can be manipulated, changed, or controlled. So in my study, dependent variable is always active variable. Like for my study, PM 2.5 particle level. Today it is 120 cubic millimeter. Yesterday it was 150 cubic millimeter. Tomorrow it will be maybe 30 cubic millimeter. Day after tomorrow it will be 200 cubic millimeter. So it is changing. That can be changed, manipulated, or controlled. Okay. By introduction of electric vehicle, I am going. I am controlling it. I am trying to reduce it. So that can be controlled. So that is my active variable. Attribute variable means the variables which are attributed to our personality. Like my age cannot be modified. My gender cannot be modified. Okay. My maybe socio-economic status to some extent can be modified, but maybe education or maybe current income, all these things cannot be modified. So these are the attribute variables. Those variables cannot be manipulated. Can you change your age? Can you change your gender? Right? So somebody is male, you have to write male only. Okay, everybody will write male, right? So these are the attribute variables that cannot be controlled or changed. Based on the unit of measurement, those are categorical variables and continuous variables. So what is meant by category? Category means discrete categories. Now suppose there are 40 students in this class. So what I can say, there are 20, suppose there are 20 males and 20 females in the class. So I will quote it as a 20 males and 20 females. I cannot say that there are 19.5 males and 21.5 females in the class. Okay, there will be either 19 males or 20 males or 20 males. Means it's a discrete number. It's a separate number. It's a full number. It cannot be expressed in terms of fraction. When you cannot express in terms of fraction, it is called as categorical variable or discrete variable, and it is measured with the nominal and ordinal scale. So after this lecture, we will discuss about what is measurement scale. Okay. So nominal and ordinal scale, they are generally used in case of qualitative studies. Whenever you express your data in terms of words, whenever you classify your data, you just classify your data or you put some order. So that is a categorical or discrete kind of variable. And continuous variable means when you express variables on the fraction of scale. Suppose if you see a measurement scale maybe will have measurement from 1 centimeter to maybe 12 centimeter. So between 1 and 2 centimeter, you have different fractions, 1.1, 1.2 till 1.9 and then 2 centimeter. So 1.1 is a fraction, 1.2 is a fraction, 1.3 is a fraction, means 1 plus 0.1. So when you express something in terms of fractions, it is called as a continuous data, like a continuous scale. So age you can express as a continuous. Age is continuously increasing by minute, by second, by week, by day, by month. Okay, by year, it is continuously increasing, right? Attitude score, when you have some type of attitude, maybe of using mask, maybe using sanitizer, maybe maintaining social distancing, that is you are measuring somebody's attitude, positive attitude or negative attitude. Okay, so whenever you have such kind of scales, you call it as a continuous. Continuous means you can measure in terms of fractions. Okay, that is a continuous variable. Now, categorical variables, again, it has three categories: constant variable, dichotomous variable, and polytomous variable. Constant variable has only one category. Like example, taxi, tree, car, like anything. It's a single category. There are no multiple categories. Dichotomous means there are two categories like male, female, yes, no, good, bad, head, tail, up, down. So whenever there are two possibilities, you call it as a dichotomous variable. And whenever there are more than two possibilities or more than two categories, that is called as polytomous variable. That is, suppose some religion in India, there are multiple religions: Hindu, Muslim, Sikh, Isai. So there are so many religions are there in India. So it's a polytomous variable. Or political parties, there are so many political parties in India. So that is also polytomous variables. Or if you are measuring somebody's attitude, so when you put it on the scale, like strongly favorable, favorable, uncertain, unfavorable, strongly unfavorable, then it has multiple categories, multiple attitudes, expression of multiple attitudes. So it is polytomous variable. Okay. And continuous means that is used in quantitative study. Whenever you are doing a quantitative study, like I am measuring my dependent variable and it is a quantitative variable. Quantitative means I am measuring in the form of number or numerals, like 120 cubic millimeter, 120.2 cubic millimeter. Okay, so that way I am measuring it. So it is a continuous variable or it is variable for quantitative study. Generally, such type of variables are present in quantitative study, and the measurement scale is interval and ratio scale. Okay. So based on the unit of measurement, we have categories like constant, one category, water, tree, taxi. Dichotomous means two category, yes, no, good, bad, rich, poor, day, night, male, female, all these are dichotomous. And polytomous means multiple categories, political parties, age, when you see old, child, young, or income, high income group, middle income group, that is polytomous. When there are more than two categories, it becomes polytomous. Continuous means when you express in terms of numbers or fractions, it is called as continuous. You can say that somebody's income may be 100.5 rupees, okay, or 101 rupees. So you can express in terms of full fractions, or you can express in terms of discrete numbers. That is possible in case of continuous scale. Age is again continuous, weight is again continuous scale, right? Now we have one more category, that is qualitative and quantitative. Qualitative means when you express in terms of text, it is qualitative variable. And when you express in terms of number, then it is a quantitative variable. Like suppose gender, if you express it as male and female, you cannot number the gender. You have to write male and female, then it's a qualitative. Educational level, high education, average education, low education, that is qualitative because you are expressing. Age is old, young, and child. When you write the person is old or the person is young or the person is child, it is qualitative. And when you write 42 years, 30 years, 48 years, 100 years, that is quantitative, right? So when you express in terms of number, it is quantitative. When you write in the words, it is qualitative. Income, high income group, middle income group, low income group, that is you are writing in the form of text. But when you are mentioning the amount, 100 rupees, 200 rupees, 300 rupees, then it becomes quantitative. Temperature, hot and cold, that is qualitative because you are expressing in terms of words. But when you say it is 98 degree, 99, 98 degree Fahrenheit, 99, 100, so it is quantitative. You are expressing in terms of numbers. So all the variables now, measurement scale in the research. So whenever you have some kind of variables in your study, especially dependent variables, these are outcome variables. And you have to measure the outcome variable because the magnitude of outcome variable changes. There is change in the outcome variable. Independent variable will not change. Independent variable will have its influence all the time. But the quantity, the magnitude, the strength, the association will change for that dependent variable. And hence we want to measure that change. Basically, what is expected or what you do in your research, you measure that change. Okay, so to measure that change, we require certain kinds of scales, and these are 4 scales for your research. First is nominal scale, second is ordinal scale, third is interval scale, and fourth is ratio scale. So these are the 4 scales which are used for measuring any kind of research variables, right? So nominal scale and ordinal scale, they are used in qualitative studies mostly, and interval scale and ratio scale, they are used in quantitative study. So why it is so, we will see in next slides. Now, what is meant by nominal scale or classificatory scale? So nominal scale means it is just nominating you. It is just classifying scale, right? It is not giving any additional information. Now, suppose I want to classify PhD batches. I will classify it as a PhD batch of 2023, PhD batch of 2022, PhD batch of 2021. I am not saying that PhD batch of 2023 is superior than 2022 or 2021. I am not doing any further comments. I am not giving any ranking. I am not putting any order. I am just saying that there are different PhD batches like PhD batch of 2022, 2023, 21. So these are the batches. Or one more example is that suppose there are 40 students in this class. I can say that there are 20 males and 20 females in the class. Okay, I am not saying that males are superior in academics than females or females are superior in academics than males. I am not commenting anything. I am just classifying your class based on the gender. So gender is my variable, and how I am measuring it? I am measuring on this nominal scale. I am just classifying it. I am not giving any ranking. I am not giving any order. I am not putting in terms of any number. I am just saying that this class I can classify based on the gender, that is males and females, 20 males and 20 females in this class. Okay, so that is a classificatory scale, or that is a nominal scale. So what is nominal scale? It enables the classification of individuals, objects, or responses based on a common or shared property of a characteristics. So what is the common or shared property for your batch? You have different subjects, but you are a January batch of 2023. Okay, PhD January batch of 20. That is a common characteristics. And from that, I am classifying you based on your gender, like 20 males and 20 females. But I am not giving any comments. There is no natural order. Can you say that males are superior than females or females are superior than males? There is no natural order, right? When there is natural order, then you can say it is ordinal scale. But when there is no natural order, in this case, there is no natural order. I am just saying that there are 20 males and 20 females. It is not giving any message. It is just nominating you. It is just classifying you. Means a person will be either belong to male group or female group, right? So that is just classification. It is just nomination. Hence it is called as a nominal scale. Not a measure of quantity. It doesn't give any quantity. It doesn't give any quantification. Measures identity and differences. So you will either belong to male group or a female group. Okay, so it will give you identity that you are from a male group of this particular batch. And differences. These are the males and these are the females. People either belong to a group or they do not. So males will either belong to one person will either belong to male or female group, right? They are categorical, discrete. Categorical and qualitative. Categorical means it is a discrete. I can say that 20 males and 20 females. Can I say that 19.5 males and 21.5 females? It is not possible. Okay. So whenever you express such things like males and females, number of students, you have to express in terms of discrete numbers or categories. Okay. That is categorical cell. So it is always categorical. So why it is categorical? In the previous slide, we have seen. Just now we saw this classification of measurement scale. So categorical or discrete scale has nominal and ordinal level of measurements. So all the variables or all the categorical variables or all the discrete variables, they are measured on nominal and ordinal scale, right? So you understood why it is nominal?
We have the census that takes place.
Mm-hmm.
It says in 2011 there were so many literate, so that doesn't come to any confusion. And it's the survey.
That is nominal.
So that will be
That is nominal scale. Yeah. Survey, like whatever surveys are taken in that survey law or census. Census is nominal scale. Yeah, it is on the nominal scale. There are few examples here. Examples are given. Eye color. Suppose I classify your batchmates based on their eye color. Some of you may be blue colored, brown colored, green colored. So based on the eye color, I classified your batch. I am not commenting anything. I just classify you into those who are blue colored, those who are brown eye colored. It is color of eye or green eye colored. Okay. So I have just classified your batch. Or gender, males and females, just classification based on gender. Or another classification that married, single, divorced, widowed. So it is just a classification. It is not giving any further information. It is not further categorizing. Okay. So nominal scale is basically what? It is a classificatory scale and it has no natural order. So always remember, whenever there is no natural order, it is called as a nominal scale, classificatory scale, or it is the basic scale of the measurement scale of research. Now coming to next level, we are moving to next level. So nominal scale was basic scale. It was just classificatory scale. Okay. Now what I am doing, suppose I am conducting one test for you, a test of 100 marks. And the topper is 84 marks and the last person, like suppose there are 40 people, the first person, the first rank scores 84 marks and the last person scores or the 40th rank scores, suppose 40 marks. All others will fall between the 4 and 40. Means there is an order. Is it a natural order? The person who scored highest mark, 84 marks, is a topper of your batch. So is it a natural order or is it artificial? It is acceptable. It is acceptable because it's a competition. It's an exam. In this exam, the person who scored highest, it is academic exam. In this academic exam conducted for 100 marks, the person who scored highest is the topper. That is a rank number 1. So ordinal scale does what? It orders you. It ranks you. Rank you based on certain characteristics. Okay. Certain characteristics means the characteristics which are common for you. Right. So in ordinal scale or in a ranking scale, there is an order and that order is natural order. That order is having some kind of importance. Okay. Like nominal scale, in nominal scale, there is no natural order. There is no importance. When I say there are 20 males and 20 females, there is no order. Nobody can say that males are superior or females are superior. Okay, but when I say after conducting a test for your batch, the person who scored 84 mark is a rank number 1. So it is acceptable universally. Everybody will accept, right? So there will be rank number 1, rank number 2, rank number 3, up to rank number 40. So it is ranked, it is ordered. That order is based on what? Order is based on the academic achievement or the marks scored by you people in that particular test. Okay, so ordinal scale has all the properties of nominal scale. So ordinal scale, basically it is one step ahead of your nominal scale. Nominal scale is basically classificatory scale. So ordinal scale will have all the properties of nominal scale, means it will classify you people. Okay, it will classify you people for this particular test. This particular test, like all people are appearing for this particular test, maybe males or females. Apart from classifying, what it will do, it will rank you. Okay, categorizing individual objects, responses or properties into subgroups on the basis of common characteristic, but also rank the subgroups in certain order. So after exam, you will be ranked. Currently, initially what I am saying, you are the students of this PhD batch of 2023. Okay, I'm just classifying you. Maybe I can say that there are 20 males and 20 females. I will distribute the papers, and then what I will do, I will rank you. It will not matter me whether you are male or female. Rank number 1 may be male or rank number 1 may be female. It doesn't matter. The person who is rank number 1 is always superior than rank number 2. Rank number 2 is superior than rank number 3. Rank number 3 is superior than rank number 4. Okay, so there is order of natural importance. Or suppose I conduct a race, running race on the ground for all you 40 people. The person who is running fastest, he will reach first, and the person who is running slow, he will reach last, right? So the person who run fast, he will have first place, and that is a natural order. Okay, that is a running race, and for that race, the person who reaches first or the person who secure first place is rank number 1. The person who reaches last, that is a rank number 40. Okay, and that is a natural order, and that is a ordinal scale. I am giving order. I am ranking you people based on what? Based on running capacity, running capability of you people, or maybe academic capability or intellectual capability. Okay, any variable may be anything. Okay, but I am judging you, or I am ranking you, or I am giving you order. When I put you into order, when I giving you rank, that is called as a ordinal scale or ranking scale. It designates an ordering greater than, less than. So here we say that the person who scored highest mark is superior than rank number 2. Rank number 2 is superior than rank number 3. Rank number 3 is superior than rank number 4 in terms of academic achievement. Okay, what is variable? Academic achievement or intellectual capacity or test result. You can simply say test, that particular test result. The ordinal level of measurement described variables that can be ordered or ranked in some order of importance. So there is order of importance. Everybody will say that this is an important order. When I rank you from rank 1 to 40, it is not by chance. It is not by influence. Okay, so the person I like the most is rank number 1. It is not like that. Okay, so the person who secures highest mark will be rank number 1. Similarly, in the race, the person who finishes first will be rank number 1. Right? So it is not, it has certain order, natural order or order of importance. Example, just now I gave you 2 example. Your example mentioned is finishing place in a race, that is first place, second place, or consecutive places. Okay. Any doubt in this? Ordinal scale or ranking scale? Easy to understand?
When we are talking about temperatures,
in
terms of a person, so will that come as ordinal?
I'm coming to that. So next is interval scale. Now interval scale is what? There are intervals, right? Interval scale will have all the properties. It is next level of measurement scale. Basic scale was classificatory or simple scale, that is nominal scale. It was just nominating. In the second place, there was ordinal scale or ranking scale, and it was ranking you people or ranking the people or objects on the based on the characteristics. Now third level is interval scale. So what is interval scale? Interval scale will have all the properties of this nominal scale and ordinal scale. Means it will classify the individuals, it will rank the individuals. Apart from classifying and ranking, it has one more characteristic, that this scale will have equally spaced intervals. The interval between two the interval between the measurements will be equal. For example, temperature. Like when we say 98 degree, 99 degree or 100 degree centigrade. Suppose above 99 degree centigrade, you can say the person is having fever. Below 99 degree, the person is not having fever. But the distance between 98 and 99 and 99 and 100, the distance is equal. The amount of increase in the temperature, the magnitude where the temperature rises is similar between 98 to 99 or between 99 to 99 to 100. So that interval is equal interval. They are spaced at equal intervals. When such thing happens, or when the temperature rises from 97 to 98 and from 98 to 99, whatever change is happening, the change is equal. So whenever we have such equal intervals, that is called as interval scale. In interval scale, it is not a full scale. It is not an absolute scale. Okay. I am repeating once again, interval scale, ordinal scale and nominal scale. They are not full scales or absolute scales. Full scale or absolute scales means what? The mathematical calculations are not possible in these three scales: nominal scale, ordinal scales and interval scale. In case of interval scale, zero is always arbitrary zero. It is proposition. We say that temperature, how do we measure temperature? Like 0 degree. 0 degree is arbitrary point. What happens at 0 degree? Water turns into ice. Okay, so it's a 0 degree temperature. It's a arbitrary point. It's a imaginary point. Imaginary means what? Suppose I am carrying 0 rupees in my pocket. I am carrying 0 rupees in my pocket. Means can I say that I have no rupees in my no money in my pocket? I can say that. When I say I have 0 rupees in my pocket, means there are no money in my pocket. I cannot buy anything from the market. But when I say it's a 0 degree temperature, and if you touch, what you feel? You will feel cold. Means there is temperature. Can I say that there is no temperature? Zero temperature means you cannot say that there is no temperature. It's an arbitrary point. At this particular point, water turns into ice. So this is a point which is designated by humans. It is an arbitrary point. It's an imaginary point. There are so many theories which we learned in physics, right? We imagine so many things. Current is flowing, or maybe ice is converting, water is converting at this particular point of time. So all these are imaginary points. These are not actual points. These are not absolute points. So that is a characteristics of interval scale. Interval scale will have a starting point that is always arbitrary point. Okay, it is not a true point. It is not absolute point. Means mathematical calculations are not possible in case of interval scale. Mathematical calculations means addition, subtraction, division, all these things are not possible. Why these things are not possible? Because there is equally spaced intervals. Only there is presence of equally spaced intervals, but zero is not absolute zero. Mathematical calculations are not possible. Means if I say there is one temperature of 20 degrees centigrade and other temperature is of 40 degrees centigrade, you cannot say that it is 2 times hotter. Means 40 degrees centigrade cannot be 2 times hotter. You have to measure the intervals. You can measure the intervals, but you cannot say that 20 degrees centigrade is 2 times colder or 40 degrees centigrade is 2 times hotter. Means you cannot have 40 divided by 2 in case of interval scale. Means mathematical calculation. Here what you are doing when you are saying 40 degrees centigrade is 2 times hotter than 20 degrees centigrade. Here you are using division formula of mathematics. 40 divided by 20, 2 into that 1:2 or 2:1. So you cannot say that it is 2 times hotter or 2 times colder, because zero is arbitrary. Your 0 point is arbitrary. So that interval you can measure, that much of interval you can talk in terms of interval. These many intervals are present. But 20 degrees centigrade is 2 times colder, or 40 degrees centigrade is 2 times hotter, or 80 degrees centigrade is 4 times hotter, or 2 times hotter to 40 degrees centigrade. That all those things are not possible in case of interval scale. Okay.
Simple mathematics.
Not mathematics, like mathematical calculations are not possible in case of interval scale. No need of mathematical calculation. There is an interval. You can say that 98 to 99, whatever temperature rise is present, the same temperature rise is present between 99 to 100 degrees centigrade. Okay, so you will have an interval. The interval between 98 to 99 and 99 to 100 will explain you that the gap is similar. The interval is similar. The interval is measurable. Whenever you measure that interval, it is of equal value. It is of equal magnitude. The magnitude is same. The magnitude is not changing. So that is the interval scale. So all of you understood interval scale. Okay, so most important point of interval scale, it will have all the properties of nominal scale, ordinal scale, and it will have arbitrary 0 point. It is not a full scale. It is not absolute scale. Means you cannot do any kind of mathematical calculations on interval scale. Okay, the points are arbitrary. Okay, points are imaginary. The starting point is imaginary. Okay, the most important characteristic, there are intervals, equally spaced intervals, hence it is called as interval scale. So interval scale has, I'm reading this, whatever is written. Interval scale has all the properties of ordinal scale. That is, individuals or responses belonging to subcategory have a common characteristics, and the subcategories are arranged in ascending or descending order. Ascending or descending order means ordinal scale. So it has properties of nominal scale as well as ordinal scale. In addition, an interval scale uses a unit of measurement that enables individuals or responses to be placed at equally spaced intervals. So the responses are placed at equally spaced intervals. That is a characteristic of interval scale. In relation to the spread of variable. Suppose spread of variable is from 0 degree to 100 degree centigrade or 100 degree Fahrenheit. So intervals are equal, 0 to 1, 1 to 2, 2 to 3. All these intervals are of equal magnitude. The starting and terminating points and the number of units intervals between them are arbitrary. So I explained you this. The starting point is arbitrary. All these points are arbitrary points, okay? And vary from scale to scale. So there is no possibility of any kind of mathematical calculation on these arbitrary points or imaginary, because it's imaginary. It is not actual. Okay. So these are just imaginary points. It designates an equal interval ordering. So basically, there is order. So we can say equal interval which are placed in terms of orders. Order means what? 98 degree centigrade, there is no fever. 99 degree centigrade, there is fever. 100 degree centigrade, maybe mild fever. 101 degree Fahrenheit, there is high fever. And then 102 degree Fahrenheit, very high fever. So that way you can, means there is order, right? There is natural order. Even for this interval scale, there is natural order. So it is interval with ordering, with ranking. Hence it is called as interval scale. Interval level of measurement describe variables that have more or less equal intervals or meaningful distance. So that distance should be meaningful between 98 to 99, 99 to 100, 100 to 101. That meaning is equal, of equal magnitude. Whenever you measure this distance, that is equal. Example, temperature. Just now I gave you example of temperature, whether it is in Fahrenheit or Celsius. It is interval scale. Again, common IQ test. IQ test is one more example of interval scale, which is measured on the interval scale. Any doubt? Anyone on the three scales? Nominal scale, ordinal scale, and interval scale?
No, sir.
Now coming to next scale, that is called as ratio scale. Now ratio scale means it's a full scale. It's an absolute scale. Absolute scale means all mathematical manipulations are possible. All mathematical calculations are possible. And zero is never arbitrary in case of ratio scale. Zero is absolute zero. Like when I am saying I have zero money in my pocket, I have no money in my pocket. I cannot go outside, cannot buy anything. I can go outside, but I cannot buy anything from the market. Okay. When I have zero money in my pocket, I cannot buy anything anything from the market. Suppose I have 1 rupees in my pocket and my friend has 100 rupees in his pocket. So what can you say? Can you say that my friend is 100 times richer than me? Yeah, you can say. Or you can say that he is having 100 times money than me. Or I can say I am having how much fraction? 0.01 fraction of money as compared to my friend. Means
somebody has pain which is 0 on 10 scale. So that is actually 0. He or she does not feel any pain on that day. And then somebody or next day.
That is the order. You have given the order. It is ordinal scale. When you are talking in terms of like 0 is no pain, 1 is mild pain, 2 is moderate pain, 3 is severe pain, 4 is very severe pain. That is the order. You have given the order, but mathematical calculations are not possible. You can here it's you have designated it. You have designated this order. You have given the order. This is the ordinal scale, but you cannot say that it is a ratio scale. Mathematical calculation means ratios are not possible. Here what I am doing 100 divided by 1 or 1 divided by 100. When I do 100 divided by 1, what you can say, my friend is 100 times richer. Or when I say 1 divided by 100, it is 0.01. So how much amount of money I have as compared to my friend? 0.01 times or 0.01% of money I am having in my pocket. Okay, so that is possible, means ratios are possible. In case of ratio scale, it's absolute scale. Zero is not arbitrary, it is actual zero. Zero has actual zero meaning. And mathematical meaning means mathematical meaning is possible in case of ratio scale. Mathematical calculations are possible in case of ratio scale. Okay, it is also called as absolute scale or full scale because zero is not arbitrary. Zero is always a starting point. A ratio scale has all the properties of nominal, ordinal, and interval scale. So ratio scale is a full scale. So as it is full scale, as you can treat it as a mathematical scale or the scale which can have all kind of mathematical calculations or manipulations. It covers all other type of scales, means it has all the properties of nominal scale, like it will classify, it will order, and it will have equally spaced intervals if needed. Apart from this, it has a starting point fixed at 0. Okay, just now I explained you that it has a starting point which is fixed at 0. Therefore, it is an absolute scale, right? So why it is called as full scale or absolute scale? Because the starting point is 0, and as there is starting point 0, so all the mathematical calculations are possible. The difference between intervals is always measured from 0 point, right? This means ratio scale can be used for mathematical operations. Means all kind of mathematical operations are possible in case of ratio scale. The ratio level of measurement describe variables that have equal intervals and a fixed 0 or a reference point. So we have a reference point here. It's not an arbitrary point. It's not a imaginary point. It is actual 0, means 0 point. It is a starting point. When measurements have the properties of first 3 scales and additional property that ratios are meaningful, the scale of measurement is called as ratio scale. Means ratios should be meaningful. Like when I am saying that my friend is having 100 rupees in his pocket and I am having only 1 rupees. So you can say that 100 divided by 1, or you do 1 divided by 100. You do in any way. It will give you some kind of information. Either my friend is having 100 times money in his pocket, or I am having 0.01% of money in my pocket. Okay, as compared to my friend. Means ratios are meaningful. When I am doing it, ratio means what? It is a division. You are dividing in either way, 100 divided by 1 or 1 divided by 100. So these ratios are meaningful. Whenever ratios are meaningful, it is called as a ratio scale. All the quantitative study or many quantitative study, they uses ratio scale. Like my study is a quantitative study. That is electric impact of electric vehicles on maybe PM 2.5 particle level. How am I measuring PM 2.5 particle in terms of quantity? 120 cubic millimeter or 120 cubic millimeter or 150 cubic millimeter. So all that is a quantity, right? And that quantity means it's an absolute goal. It's a ratio scale because 0 PM 2.5 particle level means there is no PM 2.5 particle level in the air. Okay, so it's an absolute scale, right? So you just apply 0 and see whether it is possible. If it is fitting into that, then it's a ratio scale. It's a quantitative scale. For quantitative study or for quantitative variable, we use a ratio scale. Okay. So what we discussed today, we discussed about 4 scales. These 4 scales are nominal scale, ordinal scale, interval scale, ratio scale. Nominal scale is basic scale. Basic scale means it's classificatory scale. I am just classifying you based on a particular characteristics. Like based on eye color, I will classify your badge, or based on gender, I will classify your badge. Okay, so I'm just classifying. I am not commenting anything. I am not saying somebody superior or somebody is inferior. Greater than, lesser than is not done. It is just a basic nominal classificatory type of scale, that is nominal scale. Second is ordinal scale. Here I am ranking you people based on some kind of test. I am conducting a test of 100 marks and the marks are given. Based on your marks, I am ranking you rank number 1 to rank number 40. So there is order, natural order, okay, or order of importance that is accepted by everyone. When there is natural order or order of importance, that is called as ordinal scale. Interval scale means it has all the properties of nominal scale. It will classify and it will have ranking properties also, or it will have order also. Apart from that, it will have equally spaced intervals, but there is no absolute zero. Absolute zero is missing. It's an imaginary zero. It's an arbitrary zero, like a temperature. 0 degree temperature means there is some temperature. You cannot say 0 degree means there is no temperature. Okay, it is not possible, right? Like zero money means no money. That is possible because it's a ratio scale. Okay, or income is measured on ratio scale, money is measured on ratio scale, but temperature is measured on interval scale. Means zero temperature means you cannot say that there is no temperature. There is some temperature. Once you touch 0 degree, you will feel cold, right? Ratio scale, it's a only full scale or absolute scale where starting point is 0 and all mathematical operations or manipulations are possible in case of ratio scale. Okay, whether it is division, product, addition, subtraction, everything is possible in case of ratio scale. Okay, so these are 4 scales. Whenever you are conducting any kind of study and when you want to do analysis, first you have to identify the variables and that variable measurement scale you have to apply. So once you have a variable with its measurement scale, then you can use different kinds of softwares or you can use simple calculations. There are different formulas to arrive at a particular conclusion. So you will classify based on your variables, how you have measured your variable for your objective or maybe objectives. You have multiple objectives, multiple variables. You have to identify the variable and their measurement scale. Okay. So by next lecture, try to identify variables of your study, right? If you have done with your research problem, try to identify variables of your study. That is your assignment, and identify the measurement scale, right? Identify the measurement scale for your study. How will you identify the variables? You identify the variables based on this classification. Already I have shared PPT with you all. So based on classification, you see where your variables fall, whether your variables are definitely independent and dependent variables. If it is cause and effect relationship kind of study, they will be present by default. Try to identify other variables like extraneous variables and intervening variables, whether they are present or absent in your study. If they are present, up to what extent they have their impact on dependent or on dependent variable. Okay. Then also I try to identify active variables, attribute variables, qualitative variables, quantitative variables. It is just a classification. Means you can say that my variable is this variable is independent, this variable is dependent variable, these many extraneous variables, this is intervening variable. These are the qualitative variables, these are quantitative. Qualitative means what? When you say gender, gender is a qualitative variable for your study. Suppose you are dealing with the population, you are dealing with a human being. When you say gender, it is a qualitative variable. When you say age, it is a quantitative variable. So try to identify such kind of variables. Okay. So continuous and discrete variables, again, describe whether you have constant variables or dichotomous. Dichotomous means two categories, male, female, that is two categories. Polytomous means multiple categories. So see whether there are multiple categories for your thing. Like just now you asked about the category, 0 pain scale. 0 means no pain, 1 means mild pain, 2 moderate pain, 3 is severe pain. Okay, so these are the category. This is polytomous category. So it's a discrete category. It's a categorical variable that is falling under polytomous discrete categorical variable. So that way you find out the variables of your study. After you find the variables, try to classify your variables based on these 4 points. Whether your variable is nominal variable, ordinal variable, or interval variable or ratio variable.